Cool. So that kind of ends for section 11. And I kind of want to go into section 12, which I don't usually have a whole lot to talk about section 12 because mostly I'm introducing the project. So I'm going to let you guys know that right now. So the first thing I want to say is some notes about the project. So section 12, the way I view this is kind of like telling you how to do the project. It's kind of like showing you what the project is. And the project really is the data science lifecycle, minus a couple parts. And I'll talk about what this is. In general, basically, and the curriculum has a lot more information on this, but basically know that these are things that I would say like you will definitely have these imports. Stats models, to do your linear regression. Seaborn, it's a nice way to plot. I would definitely use this, and Matplotlib. And of course, Pandas and NumPy. These are probably the main ones you'll have to do. You might have other imports if you want to use some extra libraries or do something fancy or do something that you found interesting online on Stack Overflow or whatever. But these would probably be the main ones that you'll have to use that I would expect pretty much everyone have most of these, if not every single of these libraries, okay? Now this comes down to the different data science lifecycle. So if you remember our data science lifecycle, which I should have kept that picture up, but if you remember from the very beginning was like basically talking about getting the data, cleaning the data, and so on, going exploration, feature extraction, modeling, and then from modeling going into the business case and getting that whole circle. That's kind of what the data science lifecycle really is talking about. And there's a couple ways you can do it. The main ones that the curriculum talks about is CrispVM and Awesome. I particularly seen a lot of people use more Awesome. That just tends to be more of the, and I don't know how people pronounce it. Sometimes I call it Awesome. I think of like Awesome, but with a weird twist on it. This tends to be the more popular method that at least that I've noticed. I could be wrong in certain circles. CrispVM is also another one. Basically, it's a way to do the data science lifecycle and approaching it, and it's doing the same stuff. Basically talking about the business case, who's it for, your understanding of the data itself, like where did the data come from, what are you trying to target, what should these things look like, that kind of stuff. Curriculum goes through a whole bunch of this stuff. Data preparation, basically, essentially you can think of like cleaning, okay? And then modeling, which is like your linear regression. You can do things, for example, we haven't talked too much about some of these things like validation, but basically this would be your whole modeling step. And then evaluation of saying, okay, how good was my model? How was it good? And then deployment, in this case, deployment might just be like informing the business case users and stuff like this. Or it could be actually putting this out, I just realized this is misspelled, but using this for, like using it for like some product or whatever, like putting into a pipeline. That's what deployment means. Awesome, I kind of like the structure of it better. The way it has is obtaining the data, which we kind of get rid of. We don't really have you to obtain the data in this data project. Scrubbing, which is kind of, you can say like cleaning your data. Okay, so mostly we're gonna talk about like cleaning data or scrubbing data. Exploring, basically does visualization, seeing if there's patterns, seeing if there's what the distributions are, different trends, all that stuff. Then modeling, basically after you see these parts, you'll do basically create features to use for your model and actually performing that model, okay? And then interpreting the data, saying like, how good was our model? Like, what does that mean? Now that we have this model that predicts things, break down the model, say what the coefficients are, what are the important features, based on that model. That's the stuff that, like, honestly, this is the stuff that people care, like business case users, basically people who are non-data science really care about. And really this is your the golden reason why data scientists are super important, because being able to interpret into words of like what the mathematics in your model actually says. Like, all right, I got this information. What does it mean? Okay, and that's what this interpreting our data really is about. Okay, so this one I'll kind of use as my basis, but I'm going to kind of go some tips, and this is all written on the GitHub this notebook that's available, right? So know that you can always go back to it. So don't feel like you have to like absorb it all right now. But for at least the project, there's nothing, we're not really gonna do any obtaining. Basically, obtaining your data is their CSV file for the project. You don't have to worry about like using, web scraping or using a SQL server and whatnot. Basically, we give you a data file, which is a CSV file, and you get all the data. There's the scrubbing part. So definitely check out the types. For example, you can change the types as type. This is a really useful one, basically finding out if there are null values, okay? Collinearity, which I think is misspelled, but collinearity, this is where you want to do some quick exploration to say, hey, what things are collinear? So you know ahead of time that things that you might have to kind of drop, okay? And then classic explorations, histograms, .hist, scatter. Box plots are really useful to actually see our distribution. Violin plots are kind of similar too, but we haven't talked about that at all. If you're interested, you can check it out. But box plots usually are just as good. I give you an idea of what things are outliers and where your mean and medians and your quartiles range from. Filtering. This one, depending how well you're feeling, this is back like from really early on, maybe like section 4 or 5. But this is really useful to figure out, like, you only looking at certain particular things. So that's something that you'll look at a lot. So make sure you, like, as you come across it, know how to filter. And then one hot encode, get dummies is usually what I end up doing for these kind of projects. There's other more advanced ways you can do it, but for this kind of project, get dummies would be more than suffice for one hot encoding. Okay. Note, if you do this and you add new columns to your data frame, my suggestion is make sure you make a copy of the data frame. So you might have like data frame, and most of the things are out of place, which means that it does the operation not on the data frame, but basically makes it on a copy. So what you can do is, like, you get your data frame, let's say df, and you might say df_clean, and that's equal to your things that you do to your data frame. That way you have a new copy and you can always go back to your original data frame. You can always like reload the data, but that's a pain. So that's why we tend to make copies moving forward. We can clarify what we're doing. Plus, okay, I'm going to say it before I forget, because I think it's the important part. So for the project, you're going to have to make a Jupyter notebook doing this process. My suggestion to you guys, and this is where I think it will save your butt so much, because it saved me so much time, is what I'll do is I'll work for like an hour or maybe even half an hour, right? And I'll work through the stuff, and I'll kind of like play around, go back and forth in the cells, run different parts. And then every like 30 minutes to an hour, I stop myself and I purposely make sure I save it. I do a kernel restart, right? Restart, and then run the whole thing from top to bottom. Okay. This way I can make sure that if I did something like data cleaning, where I went back and forth in cells, which you're like, oh, cool, it works. And then you try rerunning it for the first time again, and as it doesn't work, you catch those parts. So sometimes, for example, if you run the same code over and over and over again, it might affect things and you don't expect to do that again. That way you can kind of do a quick, like, make sure that everything works properly. Then what I do, as well as like just running it all the way through, make sure it works the way I intend it, is I might rearrange my section. So what I do is I make my notebook so you can read it from top to bottom, logically speaking, if that makes sense. So that way I can give a notebook to one of you or another data scientist, and they can look at it and they can understand my thought process of what I'm doing. Now, in reality, I might not have done this exact thought process the first time. I might have done this part and, I was like, oh shoot, that didn't work out. And I have to go all the way back and change things up. And then I might rearrange it. But in the end, when I finally have my final product, I would basically make it so it's organized going from top to bottom all the way through. Okay. That's something I wanted to emphasize. And I'll mention it again too, as we kind of, I think, introduce that project. I think I'll talk more about this on Friday as well. But I want to mention that since it popped in my head right now. But anyway, this is exploring some tips for modeling. I don't know. I don't know. I put box plot series in here. Okay. Yeah, I don't know why that's in there. Okay. It must have been a mistake. But anyway, always try something, like just something simple. Like you're like, all right, I don't know. Like just put your features in there and see what happens. And you'll probably get a bad R-squared score for linear regression, but at least you actually saw it. Visualize it. Make sure you plot out what your features look like. Like see what, what's it called? If you can, as much as possible, like if you can make little linear regression lines, I think that's super useful to understand what's going on, okay? What features actually matter? Like I said, there's ways you can do this. The curriculum kind of talks about it a little bit more, but one way is to basically say like what your strength is after you standardize your, you scale back your features to be standard or standardize them. And then really think about, does the model make sense? For example, if I see for like, let's say housing prices, and I see like the number of windows, as the more number of windows go up, the house pricing goes down, that doesn't seem to make sense to me. And I might have to re-observe, say, does this make sense? Like, why would this be true? And try to see if there's a reason behind it that maybe I didn't think of at first, or maybe something is wrong with the data or the model that I'm doing, okay? And then you can always adjust and make a new model. So you can, I would say, do commits, get commits. If you make a new model, do a commit. And then if you make a new model after that, do a new commit after that. That way you can always go back and check out what you've done before. The worst thing you can do is say, oh, I made this model, it worked really well, but I don't remember where it is or how I did it, and I can't get back to it. So Always making new ones or just making new cells and just doing frequent commits are super useful. Okay. And then last for interpret, really think about significance. Think of like what really matters, okay, to the business case, okay, and do visual plots. And this is where I'd say always, if you can, a visual plot is more ideal than just writing numbers down, okay? However, don't make your plots really, like I call it chart junk, where it's like there's a lot of information going on in a chart. So for example, going to multiple linear regression, presenting to a business case to non-technical people, never show a bunch of this because they'd look at this and be like, there's so much going on, I don't know what's going on. Even like one of these parts with all these data points, like just one of these parts might be too much data for one person to really understand, at least, you know, from a non-technical piece. So what I would probably do if I wanted to show this relationship, because this was really important for some reason, I might instead simplify it, whether that might be getting rid of some points or adjusting the alpha. So some points basically fade out more, or I might literally just make a line, like, you know, find the linear regression line through this point and just present the line, because most people understand lines pretty well. So be careful with what visuals you share, but also make it visual. That way people aren't super bored when you actually present to someone who's non-technical, okay? I know I kind of like gone through a couple things that are like, didn't really introduce the project, so I'll do that in a second. But I did want to say, because I'm running on time in case people have to leave, but this project example, which is in the study, the student resources spreadsheet from Raphael. I can't remember which one is labeled, but this one right here, I'll just send it to you guys now. But this one in particular, I think is super useful. Again, all this information is in the repository, so don't feel like if you don't save this, it'll be fine. But he does a really great job, I think, of walking through the initial steps of the project. So I would definitely watch that. So that's kind of the general like things I wanted to point out for from section 12 into the module project. So we're at time right now. So any questions before I kind of, well, let me ask you guys, are you guys cool if maybe I extend this a little bit longer than an hour? I don't know if some of you guys have to go. If you have to go, it's going to still be recorded. But would you guys let me kind of continue for another like 15-ish minutes? Thumbs up? I can see some nods. If you have to go, totally understand. It'll be recorded too. All right, awesome. Cool. So let's see here. I wanted to make sure. So, okay. So this is like the connection to module or section 12. Okay. And so going forward for the module project or the actual, what's it called? Yeah, the module 1 project. I want to show you guys. And so I know like Igor and Sarabi, you guys already have access to this as of right now. But I wanted to show my cohort because you guys haven't seen the project yet. And I'll release this, I think, today, just so you guys can check it out, so you guys can reference it. I would say strongly, make sure you finish your, what's it called? You finish your sections before you dive into the project. Ideally, I would say Monday, like maybe like get all of that done, section 12 before you dive in. Ideal Monday that you guys would have all that done. It worse, maybe Tuesday when we have our study group / office hours. So just kind of know that don't plan to try to catch up during project week. I would say try as much as possible, go through the sections. If you don't get it quite the first time, it's okay. All right. You can always go back to the sections and revisit it and everything like that. Okay. But module 1 project. Okay. What this looks like, you can read this through. I'm not going to read it to you. You guys can read and everything like that. But the main things that I want to point out is that your main part is you're going to make a Jupyter notebook, and you're basically going to follow through the data science lifecycle process, basically what module 12 is, essentially what I kind of walked you through a little bit of saying like what those parts look like. And you're making a Jupyter notebook that's well documented. Okay, and well documented means, you know, not just the code with comments in it, but in a lot of ways, like paragraphs, using the markdown to say, all right, what are the reasons I'm doing this? So the way I look at this is that you can put comments in the code when you're explaining what the code's doing, and you would use markdown either above or below your code of saying, why are you doing this? For example, if you decide to drop a certain feature, you might say in a paragraph form, you know, it might be a sentence or two, but in markdown, and say, why are you dropping this kind of thing? And then doing the code underneath that. okay, or above it or something along those lines. That's what I mean by well documented. And that will make your project also look very presentable, because in the end, this project is meant to be kind of a portfolio project that you can send to other or show to future employers or potential employers and recruiters and such. Okay, so the main thing is you're going to have a Jupyter notebook going through the whole steps process, basically like the data science life process. Okay, and this is going to be the main meat of what's going on here. Okay, and then a second part of it, so there's 4 parts in total, is your PowerPoint, Google Slides presentation. Make sure you put it as a PDF. So what I would do is with your Jupyter notebook, which will be a repo, like a GitHub repo, is just export your PDF into your GitHub repo. That way you can show that. And it really, I think it says on here, does it say how many slides? Okay, there's some part where it says how many slides it is. I would say at most, well, okay, I would say like 5 to 6 slides. So it's going to be, you're actually going to do a presentation, which is going to be with an instructor. For my cohort, most likely me. For self-pacing, it might be with a different instructor. But you'll do basically a quick 5-ish minute presentation. Not a 3 minutes, 3 minutes is way too short, but about 5 minutes, basically pretending that you're presenting it to some business stakeholders. So for example, this data, which I didn't really say, but this data is going to be housing data, basically saying features of different houses and how much they cost. And you can pretend like, for example, oh, this is for, what's it called? Losing my train of thought now. This is for a group of people who are maybe looking to invest in housings or something like that. Or maybe they're looking to flip a house and trying to figure out what things work really well for them. That's the kind of audience you should think about. The way I kind of think of it is, think of the math level that they have is like mid-high school. Not to say anything bad about business people or anything like that. It's just more like, you don't want to make it complicated, and sometimes you can get into the weeds and stuff like that. So simple graphs, simple visuals, what's it called? Nice, like nothing too complicated mathematics, okay? So that's kind of things I would make sure you have. And I say 5 minutes. And so I think on here it says like something like 6 slides or something like that. I don't personally have a strong preference to if you have more slides, because as long as you can go through those slides and the information on those slides are informative, and we'll talk about this during our office hour study groups kind of set discussion, but the important part is to have enough information to the non-technical person. And so sometimes you might have just a visual with maybe at most like a fragmented sentence, and that's all the words on there. My strong thing for you guys is don't put a bunch of words on a slide, because what ends up happening, if you guys have any experience with presentations, people just read it and they're just distracted, whether they mean to or not. They just get distracted from all the words going through. And again, this is it's not going to be literally you presenting it to a bunch of business people or anything like that, but just kind of like, that's kind of like the role, that the way we assess, right? So just know that basically the second part is going to be a PDF, some summary to the non-technical people about the things that you did in your Jupyter notebook, okay? The third thing is a blog post that says about one element, and I cannot stress this enough. Focus on one part of your project and describe it, and basically explain it in 800 to 1500 words. And I'm going to use some words from my fellow instructor, Eli. He says, don't let the perfect be the enemy of the good. Your blog post does not have to be perfect. You do not have to be an expert in that specific thing that you're doing. The important part is to be able to explain things, you know, as best you can. And what's nice is that the data science community is very open and very supportive. That's what I've noticed, is that people tend to be very open to like new people coming in and understanding things. So if you misquote something, or you say something in your blog post that isn't quite kosher, it's not going to be the end of the world. Like no one's going to like tear you apart in that sense. People are generally supportive, and if they're not, you don't need them anyway. But anyway, your blog post, that's part of your project itself. And then the fourth thing is a video walkthrough, which sounds really scary. It's not that scary. Really what it is your video walkthrough of your presentation. So it's kind of a sense like a way for you to practice more of your presentation. Kind of like walking through the non-technical piece. And I don't know about you guys, but like when I've had to do this, like where I have to make a video for like an interview or something like that, I get really like stressed out, because like I'm like, I would rather do this live, because then people are more forgiving with live. To give you a little bit, this is not going to be a major part of like your quote unquote grade. Like I'm not looking for people to edit video or anything like that. You can literally, like the way I do presentations and the way I've done study groups, which you can see how great and polished those are all the time. They're not. But the point is that you walking through it once, do maybe a take, and basically it's for you to practice a little bit and us to basically have something to reference to see how you did. But really, this video walkthrough is your PowerPoint presentation. Okay. And one last thing that I kind of glazed over, your Jupyter Notebook, which is the main meat of your project, that will be the majority of your assessment on a one-on-one, which is going to be like a 45-minute. There's a bunch of information on here, but it's kind of a one-on-one. And basically, you'll walk through with the instructor, which will likely be me, but you'll walk through that with that person of how the project, what's it called? Like you're explaining the data and your process to someone else who's familiar with data science. So you could think of it someone in your data science team. You could think of it someone like your data science manager. The point is that someone who's like familiar with data science doesn't need to go through all the nuance. So like, what's this code doing? Or say like, what is pandas? Like they're not going to ask those kind of questions, but it might be more of a conversation of going back and forth of saying, oh, can you tell me why you did this part? It's like, oh, can you show me like, like, for example, let's say, oh, there's a lot of missing values. Like, oh, what did you end up doing with it? It's like, oh, I ended up doing this with it. It's like, oh, can you show me what that looked like? And you might scroll back and forth showing those parts. So it's a much more of an informal conversation, basically talking to someone who's not familiar with the data, but familiar with data science, okay? Which is very different from the PowerPoint presentation, where really you're giving a presentation like for 5 minutes of basically saying your findings and your reason why, the things that you found in your process of the Jupyter Notebook itself. Any just general questions? I know there's a lot of information on here, but I wanted to give you guys a quick rundown of what this will look like. Cool. All right. And I'll release this today for my cohort. I know, Igor, you already have access to it. Griffin, you already have access to this too. And so just know that the rest of you guys will get it. Today I'll release it. I did want to give a couple of advice, which is also part of this notebook in the GitHub. And basically one quick thing is just your markdown. So there's a bunch of information about how to do markdown, how to make this all look pretty. Basically just the main thing is like, you're not trying to super impress anyone with your markdown or your formatting, but it can be helpful to help emphasize parts so your text doesn't get hidden within your project rundown in your new Jupyter Notebook, okay? Which includes like code snippets and stuff like that, okay? Some other general advice, is, I talked about this, using Jupyter, restart your kernel. I would say like force yourself to do it every like 30 minutes to an hour, restart the kernel and just run it top down to make sure that it runs properly. Because if you know it runs at least properly when you restart it, then you know that someone else can run it, which can be really not just frustrating if you're someone else who's giving it, but also I like to say like past Victor loves to mess with future Victor, because past Victor will do things that future Victor does not agree on or does not remember why past Victor did it. And so this will help you prevent those kind of issues where your past self essentially did something and you're not, and you look at it again, you're like, wait, what happened? Like, it's not working anymore. This kind of helps you prevent that happening and basically periodically going through your kernel and restarting and running it down, okay? And make sure you do that in active environment. That way you are running the same stuff over and over again, because you might get, if you're running a different environment, you might get different results depending on what you're doing, okay? But that's some general advice. Again, there's information here, how to order things, but this is just to make the Jupyter Notebook look pretty. Okay. Cool.